Hello engineers, welcome to another video on low-level design. In this video, let's look at another creational pattern which is called the abstract factory pattern. I hope you're ready. Let's get started. So let's first start with the intent. The intent for abstract factory is like this. Provide an interface for creating families of related or dependent objects without specifying their concrete classes. So the important words to see here is families. So we're trying to create a family of objects which are either related or dependent with each other. So we are trying to create not just one object, but we are trying to create a family of objects that work together to create some kind of a global product, right? So that's the idea behind abstract factory. So we are going to build a factory without specifying a concrete class. We're going to delegate the object creation to the subclasses, but we are not just going to deal with one object. We are going to deal with a family of objects, right? That's the idea behind abstract factory. So where can this abstract factory be used? So let's have a look at some examples. The first is widget families. I think this is a good example of an abstract factory. So we have so many apps on our phones. So the same app, let's say a calendar app, has some widgets designed for the Android ecosystem. There are some widgets designed for the iOS ecosystem, right? And if I'm installing something that is cross-platform, like the same Google Calendar application is available on both iOS and Android, and I want to provide widgets for that application, there are going to be several widgets, right? A small one, a big one with a detailed today view, and so on. So this family of widgets across platforms is a good example of an abstract factory. So we build one family for iOS, we build one family for Android, and both of them can be created using our abstract factory, right? So that's one of the examples. So anything that is cross-platform, you can think of them as a good example of abstract factory. Maybe browser extensions, maybe desktop apps that are available in both Mac OS and Windows OS. So where we want to change the look and feel of the application, we can make use of abstract factory. So another example is assembly units. We're going to code this one. So let's say we are a manufacturing unit and we are assembling computers. And we get parts from everywhere and we are trying to assemble a computer and sell it. So let's say our assembly unit has one factory that takes care of assembling Apple computers. It takes in an Apple CPU, Apple motherboard, Apple operating system, which is the Mac OS, and then assembles it and ships a computer. And then on the other side, we have another factory that will take care of shipping Dell computers, let's say. So Dell will have a Windows operating system, an Intel chip, and so on, right? So the computer is the same. The kind of family is the same because every computer will have a RAM, will have a CPU, will have an operating system, and so on, right? The family is the same, but it is a variant of that family. So one factory is dealing with Apple computers, another is dealing with Dell computers, and there can be many such factories. So to manage all this at a global level, we can make use of abstract factory. And another example is game environments. This is a very good example. So when we are playing any video game, suddenly we see these Christmas themed events or Diwali themed events, right? So the gameplay does not change, the environment changes. So when the environment changes, the game developers need to create assets for that environment, right? So if it's a Diwali theme, our game character will have a Diwali outfit. There'll be Diwali themed weapons. There'll be Diwali themed decorations in the entire environment and so on, right? And they can easily switch between environments without having to change the experience of the gameplay. So that is another good example of an abstract factory. Now let's take a look at how this abstract factory is implemented. So we're going to get into the UML diagrams now. Let's go there. So in our design patterns folder, I have added a new file called abstract factory. Now let's first look at the class diagram. So we already know how to create a product from our previous factory method pattern. So if you haven't watched the factory method pattern, please go ahead and watch it because it'll be much more easier if you watch this video after watching that video, right? So let's continue. So we already know how to create a product. We'll have a product interface with some operations, and these are the concrete products that we are going to create. And these products are implementing the common interface product. This was what we have seen in the factory method pattern. But imagine there are multiple products like this. So product A is having two variants, and at the same time product B is also having two variants. And the combination of A and B, let's say, creates a family. So in our game environment example, let's say product A is our hero product B is the background. So both of them together will form the environment, right? So this will become a family. And similarly, Diwali themed hero, Diwali themed environment will be another product. So combination of these products will become a family. And now let's look at abstract factory. So this is the abstract factory. So what will it do? There is an abstract factory class and it has one public method assemble. So there can be multiple variants of this pattern, but in this variant, let's see how this is implemented. So we have a public assemble method, which will have access to two protected or private methods, create product A, create product B. There can be multiple products like this, create product C, create product D, and so on. And this assemble is responsible for calling each of these methods, create A, create B, and it will combine all of them and return a family. And this family is then used to make other operations. So for example, in factory 1, we create product A1 and product B1. So A1, B1 combined in the assembly method will create a family 1, and A2, B2 combined will create a family 2, right? So that's how abstract factory method looks like. So it's a combination of factories. So in the abstract pattern method, we saw that there was only one method called create product, and that was responsible for creating the respective concrete product and returning it. Now we are dealing with multiple products and there is one common method which takes care of them. Again, this is one of the variant. There can be other variants of passing down the factory type as a parameter and then creating the objects and so on. And that is another variant. So there is a little bit of flexibility there. So let's see how the sequence goes like. So let's say a client wants to assemble a family 1. Family 1 contains product A1, product B1. Okay, so it calls upon the factory 1 with assemble method, and the factory 1 assemble will call upon product A1 with a new object creation and will store the object somewhere, and it will call upon product B1 object creation. It will take the instance and store it somewhere, and then it will call upon the family, which will be the actual family of products, and we will take the instance of the family and give it back to the client. Now after the client has that family, the client can call upon individual operations either on product 1 or product 2 and then get the results out of them. This is the sequence in which we are going to implement this pattern. Okay, so let's see this in an example. We are going to do computer assembly. Let's say we have a computer factory and we are going to assemble a computer. So what will this assemble do? It will call upon create CPU and which will create a CPU. This will call upon create operating system, which will return an operating system. There can be many such components like this: RAM, motherboard, monitor, whatever you want to keep here. And then this assemble method is responsible for calling upon all of them and create a family of products, which will be our computer. And we have two such factories as an example. So if we go into Apple factory, we are assembling an Apple computer. And what will Apple computer have? It will have an Apple CPU and Mac OS. In the same way, the Dell factory will have Windows operating system and Intel CPU. Okay, so these are our two factories and the family is Dell computer here. And just like before, we have the common interfaces for each of the product. First product is CPU, which is an interface which is implemented by both Intel CPU and Apple CPU. And we have the operating system, which is implemented by Windows OS and Mac OS. Similarly, there can be a third product for RAM, there can be a fourth product for monitor, and so on. So we can combine all of them and create a family with an assemble method. Okay, so this is the diagrammatic implementation of abstract factory pattern. Okay, now let's try to understand all this with code. So I've created a new folder called abstract factory, and this code will be available on GitHub, and the link will be available in the description. So do check it out, right? So what do we need? If we go back to the diagram, we can start from the left. First, we need a common interface for CPU, which will be implemented by Intel and Apple CPUs. So we have a common CPU, which is a interface. It has only one abstract method operation with no implementation. And this will be called upon by Intel CPU and Apple CPU. I've just put out one method. There can be any number of methods like this, right? So this is our first product. Similarly, we have a second product, operating system, which has the same pattern. Operating system will have one virtual method, abstract method with no implementation, and Windows OS will call upon this one to perform an operation, and Mac OS will do the same. right? Welcome to Windows, welcome to macOS. So these are my two products. And what will be my family? My family is a computer. And this is how the computer looks like. Computer has a constructor which will take in two things, one CPU and one OS. And if there are more things required, we can pass them along in the constructor as well. So whatever is passed along here, so that will be set as the CPU and OS, and this will become a computer object, right? And now let's look at the abstract factory. This is our abstract factory class. We have the assemble method, which we are going to expose either as a static method or as a public method. And in this assemble function, we are creating two things, create CPU and create OS, which are my protected abstract methods, which will be implemented by the respective factories. Inside create CPU, I will have my own logic and I will return a respective CPU. Inside create OS, I will have my respective logic and I will create my operating system. And when I combine both of them, I get a new computer. So I'm creating a new computer object. I'm passing down the CPU and operating system from the previous two steps, and I'm creating a new computer. I will return a new computer. So when I call upon assemble, the return type is computer, and I will have a fully ready computer. Now let's go to Dell factory, which will implement our computer factory. So the Dell factory will implement two methods, create CPU and create OS. And inside create CPU, it will return a new Intel chip, and inside operating system, it will return a new Windows operating system. We have already seen the products beforehand, right? And we don't need to implement the assemble here because the assemble logic is the same for everybody. It will be a CPU, it will be a OS, and combined will be a computer, right? So this will be the Dell factory. And then in the Apple factory, as you can imagine, inside create CPU, we are creating an Apple CPU, and inside OS, we are creating a Mac OS. And the assemble method is already available inside Dell factory and Apple factory because they are inheriting from the computer factory, and it is a public method, so it is naturally inherited from the parent class, right? Now let's see the implementation. Let's say we want to build a Apple computer. So first we create an Apple factory like this, and then we call upon assemble. We can call upon this assemble any number of times we want, and every time we call upon it, we get a new Apple computer. Inside Apple computer, we'll have the Apple chip and the macOS operating system. Similarly, we can call upon the Dell factory and we can call upon assemble. So every time we call upon assemble, we get a new Dell computer, which will have Windows operating system and Intel CPU chip, right? So let's run this code and see. So as you can see, this is from Apple CPU, welcome to macOS. This is from Intel CPU, welcome to Windows. So we have successfully created two computers, which are families of multiple products using our abstract factory. So this is a very scalable approach. We can add any type of factories here. We can add any number of products to create the family, right? So that is the whole idea behind abstract factory pattern. Now let's have a look at some of the trade-offs of this pattern. So far we have seen the intent of this pattern, we have seen the example use cases, we have also covered the diagrams, and we have also seen code implementation. Now let's talk about some trade-offs. So the abstract factory pattern gives us a lot of abstraction. The client does not need to know how the product is assembled, how the family is assembled inside. It just says, give me an Apple computer, and the factory will take care of creating that respective Apple computer, right? So a lot of abstraction. And this provides a lot of loose coupling as well, because there is no hard implementation between the client and the factory and the products. So it's all very loosely coupled because we are using common interfaces and child classes for doing this kind of stuff. And it provides a lot of flexibility as well, because naturally this is an open closed principle implementation. We can add any number of products, we can add any number of factories, right? So those are some of the great strengths of this pattern. And some weaknesses to keep in mind: code complexity is naturally increased because we are dealing with a lot of classes and subclasses, and if things get bigger and larger, it can be quite complex to implement, right? So that is something to keep in mind. And maintaining consistency is difficult because what are we trying to do? We are trying to create a family of products, right? And even if one of the product adds a new variant, it needs to replicate in all the other families as well, right? So if there is an addition of a product, it needs to be maintained across the entire family, right? So that is something to keep in mind to maintain consistency. And it's obviously harder to debug and test because when we are dealing with unit tests, we need to test for every kind of family and every type of product, right? So it can be a little harder to debug and test as well, right? So these are some of the strengths and weaknesses of this pattern. So if you have come across any other strengths and weaknesses, definitely let me know in the comments below so that everybody can learn, right? So those are the trade-offs of this abstract factory pattern. So that's all I had for this video, guys. Thank you so much for watching. If you have any questions, definitely put them in the comment below. Do subscribe if you haven't done already. Do leave a like if you found this helpful and share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.